Hi guys, welcome to Science World Podcast. Myself Virendra Kumar, professor and scientist. In this episode of podcast, I am going to tell you about the current and resistance. So friends, do you know what is current? Whenever there is a movement of charge carriers in a substance, there is an electric current. Current is measured in terms of the number of electrons or holes passing through a single point in 1 second. Time rate of flow of charge through any cross section is called current. So, if through a cross section dq charge passes in time dt, then average current is given by dq by dt, and hence the instantaneous current can be written as current I is equal to limit time dt tends to 0 dq by dt. Regarding current, it is worth noting that current is assumed to be a fundamental quantity in physics with, with unit ampere, and the serious unit of a current is EMU of current and is also called by watt. Therefore, 1 ampere current is given by 1 coulomb per second, and that is equal to 1 by 10 by watt. The conventional direction of current is taken to be the direction of the flow of positive charge, that is the direction of field, and it is the direction of opposite to the flow of the negative charge. Current is not a vector quantity. The current density is a vector quantity. Current is also defined as flux of current density, that is integration current density dot ds. Dot product of two vector is a scalar quantity. That's why also current is a scalar quantity. A charge is conserved and current is the rate of flow of charge. The charge entering at one end per second of a conductor is equal to the charge leaving the other end per second. This in turn implies that for a given conductor, current doesn't change with change in its cross section. The conductor remains on charge when current flows through it. Current in different situations is due to motion of different charge carriers. That is, current in conductors and vacuum tubes is due to the motion of electrons, and in electrolytes due to the motion of both positive and negative ions. In semiconductors, it is due to the motion of electrons and holes, and in discharge tube containing atomic gases, it is due to the motion of positive ions and negative electrons. In case of electrolytes and discharge tubes, tau positive and negative charges are equal, and the currents due to them will be in the same direction but usually unequal due to different mobilities of the charge carriers. According to its magnitude and direction, current is usually divided into two types, DC current and AC current. The direct current is the current if the magnitude and direction of the current doesn't vary with time. It is said to be direct current. Cell, battery, or DC dynamo are its sources. Alternating current. If a current is periodic with constant amplitude and has half cycle positive and half cycle negative, it is said to be alternating current. AC dynamo is the good source of AC current. It is worthy to note that rectifier converts AC current into DC current, while inverter current converts DC current into AC current. When electric current passes through a conductor, various observable effects are produced like thermal effects, magnetic effects, and chemical effects. When a current flows through a resistance, heat is generated. Sometimes light and other form of energy are also emitted. A light bulb is deliberately designed so that the resistance causes visible light to be generated. Electric current flows very fast through any conductor, resistor or semiconductor. Actually, it is little less and it is almost equal to the speed of this light. Hence, you might have experienced the static electricity. Charge carriers, particularly electrons, can build up on things without flowing anywhere. You have also experienced when walking on a carpet floor during the winter or in a place where the humidity was very low. An excess or shortage of electrons is created on and on in your body. You acquire a charge of static electricity. It is called static because it doesn't go anywhere. You don't feel this until you touch some metallic object that is connected to the earth ground or to some large fixture, but then there is a discharge accompanied by a spark that might well startle you. It is the current during this discharge that causes the sensation that might make you jump. Hence, now I am going to tell you about the current density. Current density is denoted by capital J vector. In case of flow of charge through a cross section, current density capital J vector at any point A is defined as a vector having magnitude equal to the current per unit area surrounding that point, and it is normal to the direction of the charge flow as well as the direction in which the current passes through that point. If the cross-sectional area is not normal to the current, then in that case we will define the current is equal to J dot ds. You know, current is measured in terms of ampere. An ampere is a comparatively large amount of current. So sometimes we use terms like milliamperes, microamperes, nanoamperes. We rarely use kiloamperes. The amount of current that will flow in an electrical circuit depends on the voltage and also on the resistance. So friends, now I will tell you about the resistance and the Ohm's law. Resistance is a measure of the opposition that a circuit offers to the flow of electric current. It is the property of the substance due to which it opposes the flow of current through it. You might compare resistance to the diameter of a hose. In fact, for a metal wire, this is an excellent analogy. A small diameter wire has high resistance and large diameter wire has low resistance. Of course, the type of metal makes a difference too. Iron wire has higher resistance for a given diameter than copper wire. The standard unit of resistance is the ohm. This is sometimes abbreviated by the omega symbol. In 1828, German physicist George Simon Ohm discovered that in case of a certain substances such as iron, platinum, etc., at constant temperature, the resistance of given wire doesn't change with change in potential difference across it. That is, resistance is given as the ratio of the potential difference to the current that is constant for a given substance. That is, current is directly proportional to the applied potential difference, and this is called the Ohm's law, and the substance which obey it are called ohmic or linear conductors. A conducting device obeys Ohm's law only and only if under steady physical conditions, that is temperature, etc., remains constant. It is its resistance is independent of magnitude and polarity of the applied potential difference. Ohm's law is not universal, as it doesn't hold good in case of gases, crystal rectifiers, thermionic valves, transistors, etc. The devices or substances which do not obey Ohm's law are called non-ohmic or non-linear conductors. For the non-ohmic conductors, I versus V curve is not a straight line. In these situations, for a given voltage, the ratio of V to I gives the resistance R, while the rate of change of voltage to change in the current for a given voltage, the so-called dynamic resistance R for a voltage V is given by delta V divided by delta I. It is important to note that though resistance R can never be negative, but dynamic resistance can be negative. Friends, I will tell you that reciprocal of a resistance is called the conductance. Now I am going to tell you about the specific resistivity. The resistivity or specific resistance is numerically equal to the resistance of a substance having unit area of cross section and unit length. Hence is given by R is equal to resistivity into L by area of cross section. Resistivity is the characteristic of the material of specimen. Friends, it is important to note that resistivity is numerically equal to the ratio of magnitude of electric field to the current density. The unit of resistivity is ohm into meter. The reciprocal of resistivity is called conductivity or specific conductance, and it is denoted by small sigma. It is independent of the shape and size of the body, and resistivity depends on the nature of the material of the body. That is, resistivity is the property of a material, while resistance is that of an object. That is, with change in shape and size of a body, its resistivity remains same, while the resistance will change. Resistivity of a substance depends on the temperature of the body and in general varies with the temperature according to the relation resistivity rho is equal to rho naught multiplied with theta plus beta d theta square and so on, where alpha and beta are called the temperature coefficients of resistivity. If the temperature difference is very small, then the resistivity can be given by rho is equal to rho naught into 1 plus alpha d theta. All the substances, according to their resistivity and its variation with temperature, are divided into four classes: conductors, semiconductors, insulators, and superconductors. So, friends, we have discussed the importance of current and resistance, their definitions, and their properties. Hope you like this podcast. Please subscribe the channel and share this session with your friends and family members so that they can also learn about these important aspects of current and resistance. Thank you.